Hello, I have made a Manim plugin called MF Tools, and I'm going to make a series of videos explaining the different pieces of it and how they work. The coolest part of it is called TransformByGlyphMap. I made a piece of code about a year ago called TransformByGlyphMap, and this is an upgrade to that. So here's the problem that it solves. Have you ever found yourself trying to make an animation of an expression like this to another expression? And you want it to be nice and beautiful like that, where, one little piece just moves over to the other pieces like that. And so you write them both out in latex, and then you try to transform them, but it doesn't quite look the way you were expecting. You find it looks more like this instead. And that's not really what you were going for. It kind of smushes all the points of the latex all together. I'm probably pronouncing that wrong, whatever. It smushes all the points together. That's not what you were going for. So then you're like, oh, well, maybe I'll just look up a different one. Maybe I can do it with a different kind of transform. And that simply has a different look to it. It's still not what you were going for. So you're like, okay, maybe I can try it a different way, perhaps with a fade transform. That wasn't it. Maybe if I fade transform the pieces. Ooh, that's not bad. That's not bad, but still not exactly what I was going for. You see, none of these different transforms actually see the algebra. None of them actually understand, what's really going on inside. And so then you find transform matching shapes, and you're like, okay, surely this is going to work because it'll see that that 6 is the same as those 6s. Alas, it doesn't work because you see the shape of a superscript 6 is not the same as a regular coefficient 6, if you can believe it. They're slightly different, so that doesn't work. And then you're like, okay, well, maybe I'll try transform matching text. That will be based on the text. Well, you can, just so you know, then you're going to have to go in and put these little double brackets around the things that you want it to specifically pay attention to and match. And then you get an animation like this. And that's not bad. It did move the 6s around, but you'll see it didn't really move the cosine and sine around correctly. Perhaps we could go back in there and put double brackets around everybody. There's got to be a better way. There's got to be a better way. So how did I make this video here? Well, there's a long way to do it, and there's a short way to do it, which is the package that I'm introducing to you now. The long way to do it is like this, where you first have to use the utility function index labels to put little numbers on every little glyph so you can tell what's what, and then you can refer to those glyphs individually by, expression 1, 0, 16, expression 2, 0, 4. That's going to find the 16th glyph of this expression, which happens to be this, and send it to the 4th glyph of this expression, which happens to be this. And of course, we're counting from 0 because we're in Python. So that's what that replacement transform does. It moves that 6, in a little nice path arc of arc length pi times 0.6. And then it does the same thing to a copy of the exponent to send it to the other 6 with a slightly different path arc. And then it fades out the parentheses. And then it replacement transforms all the other glyphs, every single one of these things. It sends this letter C, or no, my bad. It sends that letter C to the other letter C. And it shifts everything around exactly the way it needs to get this beautiful result. Now, goodness gracious, what a pain. That takes so long to write. It's so very large. Now, you might be saying, hey, did you know that you can do that with a list comprehension? Yes, I did. You can also do it with a list comprehension like this. But if you've ever actually done that, you might agree with me that it's actually not really any faster to do that. You can do copy and pasting this pretty much faster than you can do this because you still have to go in there and carefully count out, okay, not the 4, not the 13. And it's like, it's still a pain. It's still a pain, even if you use list comprehension. And then the important ones, you still got to say exactly how to do it. So, how can you use TransformByGlyphMap? Let me show you. First of all, you're going to need this package, pip install mf tools. It'll install pretty quickly because it is pretty small. And then you can do it like this. So you see these two things here are identical, right? Here's how it works. We pass the two expressions to this function, or this class rather, and then we pass a certain number of these things. All of these together I call the glyph map, because it's telling which glyphs get sent to which other glyphs. It's saying that glyph 16 of the first expression gets sent to glyph 4 of the second expression, and with these quarks, with a path arc of pi times 0.6. So this is exactly equivalent to this line here, right? That literally gets converted to replacement transform, all that. It gets turned into that. And then this line here gets converted into this line here, the next one. Now, as it's going through parsing this glyph map, it's keeping track of which glyphs of the original expression and which glyphs of the target expression have already been mentioned. So it's kept track, okay, you've mentioned 16 so far and you mentioned 4 so far. And then when it sees this one, it says, aha, you already mentioned 16, so I'm not going to overwrite what you said with that 16. I'm going to make a copy of it. So that's how it knows to put a copy in there like that. And then for the next one, we're saying 0 and 15 get sent to nothing. If the second list is empty, it's not going to do a replacement transform. It's going to do a fade out. There's more things you can do, but for now I'll just say it's going to do a fade out, and then you can pass keyword arguments to that as well. And if you wanted to fade something in, you could do it in a very similar way. You would just, let me turn that off. Whoops, how do I do that again? Like that. You would just, do something like this, and that's going to fade in glyphs 1, 2, and 3 of the target object. And then you could put quarks in that if you want, or you don't have to put any quarks, you can just call it right there, and that's that. And notice that's all you have to put. All of these other ones, you don't have to tell it to do that, because you see, it's keeping track of which glyphs you have mentioned. And so once it's done parsing this glyph map, it's going to go back and look, okay, so here's all the glyphs of the original, and here's all the glyphs they mentioned. So then here's all the glyphs that they haven't mentioned. And then it's going to do the same thing for the target object. And then it's going to check, are the unmentioned glyphs of the same length? And if they are, then it's just going to send them one after the other to each other like that. So yeah, so this amount of code is all that you need in order to achieve what natively in Manim would be this amount of code. So yeah, that is the idea behind TransformByGlyphMap. Now let me show you that in action. Let's do an actual example. Let's say you want to turn this math text into this math text. So the animation that I would envision for something like that would be, we're going to take that 2 and distribute it over the parentheses. So we're going to sort of path arc it over the parentheses and join up with all 3 of those terms separately. So here's how you can do that using TransformByGlyphMap pretty quickly. First of all, you can just start by passing that. Now, it's not going to work properly if you don't pass it a glyph map, but I'll show you it will do something else very useful instead. I can run, let's see, where are we? Yeah. If I run this, it renders both expressions, of course. And it says, error. Length of unmentioned indices do not match. Indeed, we did not pass a glyph map, so it's not going to work properly. And so instead of doing a nice animation, it's going to show us the indices of both objects instead. And that will help us in making the glyph map when we need to. Here it is. So it's going to show us that these are all the indices of the first object, and these are all the indices of the second object. And so based on that, then we can fill in the glyph map. Let's give that a try. So we want this 2, which is index 0, to get sent to this 2, which is index 0. So I can go ahead and start with that. So my first glyph map entry will be 0 to 0. Like that. Next, I want that same 2 to get sent to this 6. In fact, I want this 2 and this 3 to combine together to be this 6. So let's see how I can achieve that. Well, I could do it like this. I could do 0 and 3. My bad, 0 and 4 become 3. Like that. And then for the last one, I'm going to do 0, 7, and 8 become 6 and 7. 8. What did I do there? I accidentally doubled up on brackets. Become 6 and 7. Like that. And then lastly, I want those parentheses to just disappear. So I'm going to write that like this. 1 and 9 can simply disappear like that. Okay, let's give that a look. Okay, so that's not bad. Oh, you know what I definitely should have done was add a self.weight at the end so we can take a look at the final result. But that's definitely not quite what I was going for. I was hoping for the 2 to arc over the parentheses rather than just sort of move straight through them like that. But you can see how each thing does what I told it to do. The parentheses fade away. The 2 merges up with those other ones. The other ones transform into their new values. And then all the other symbols that I didn't mention, the X, the Z, the plus signs, they just move to their new position. They don't have to be told what to do. It works it out all by itself. But yeah, so what I actually want to happen is I want that 2 to arc over the parentheses, and then I want the 3 to kind of stay where it is and just transform into the 6. So here's how I can achieve that. I can send the 0 to a 3 and a 4 to a 3 separately. And then this one I'm going to give a certain path arc of, say, well, let's see. Not very much. Let's say, like, I don't know, pi over 2. Let's see what that looks like. Oops, I forgot a comma. It's not going to work properly. Okay, as you can see, I've made a terrible mistake. I caused it to path arc under because I gave it a positive path arc when in fact that would be clockwise, so I'd actually need a negative path arc, my bad. And also I see that it's not really as big as I was hoping for, so I'm going to crank that up to maybe pi times 0.7, let's say. So let's try that. And then I also want this one to kind of path arc a little bit. So let's say pi times 0.4, I don't know. And then I have the same exact problem with this one. We'll do that next. Let's just do this first. Nice. So that looks great. So notice how that 2, or that copy of the 2, moves over and it transforms into that 6, whereas the 3 also transforms into the 6, but it stays right where it is. And then also my first 2 does just a tiny little hop to get to its new location. Okay, and then now we're going to fix the final one. We're going to give that a path arc as well. And then it was 7 and 8 also become 6 and 7. And that needs a path arc of, let's say, let's just give it a full pi. Whoops, I missed another comma. There you go. Pi's probably a little much, but there you have it. It looks like that. Zoop. Nice. And so yeah, so right now I have it where the parentheses just fade out. But let's say I wanted to go for a different type of remover. What if I wanted to uncreate them instead? Well, then instead of putting a blank list, I can just put whatever remover I personally prefer. So now let's see how it looks with an uncreate instead. I think that looks bad. Not really liking that. Let's try a different one. Let's try shrink to center. Now shrink to center is going to work, but the trouble is it's going to do so as a V group. So they're going to they're going to shrink to center as one object. And so no problem. You can just pass the parameter remove individually. Whoops. I can't spell. Individually. I mean true. And now it will remove them each as their own object, and so they'll just shrink to their own center. Let's see it again. There you go. So yeah, so many different ways that you can do it. Many different ways that you can do it, and you don't have to write this big, huge, long thing, you know, with like a separate thing. You can just mess around with changing the numbers in this little thing. And so yeah, okay, let's do one more example. So this time I have an example where it's, you know, f of x equals this function, and let's say I want to substitute 11 in for x. Sure. So again, we can do it with TransformByGlyphMap, and then I'm going to say expression 1 to expression 2, and I'm not going to put in a glyph map yet. I'm just going to leave it blank, and we'll see what it comes up with. So that's going to trigger the show indices mode once again. There are several different ways to trigger the show indices mode. That will trigger if you can either not put a glyph map at all, you can leave one of your glyph map entries, both lists are empty, you can pass the parameter show indices equals true, or you can fail to leave your unmentioned indices the same length. That's what it's complaining about there. And okay, so it's put them next to each other, and it's showing us the indices of both objects. Okay, so what do we want to transform? We want to transform this x into this 11. So that's just going to be 2 becomes 2 and 3. And then this x needs to become this 11. So that's 5 and 6 and 7. And then this x needs to become this 11, but you see this 11 also needed parentheses. So I can do it a couple different ways. I could do 10 becomes 12, 13, 14, and 15. Like that. But let's say I forgot. Let's say I just did 13 and 14 and I forgot about the fact that it's got those extra parentheses. Let's see what happens if I try to run this. Oh, I forgot another comma. Classic forgetting of commas. Let's try again. Right. So it's complaining that all of the indices from the first object and all of the indices of the second object that I didn't mention are not of the same length. So therefore, it doesn't know how to map them to each other. We have to fix it. And so that's going to trigger the show indices mode again. It's not going to try to run the transformation with the glyph map we gave it. It's just going to say, the glyph map you gave me is invalid. Here's the indices again. Try again. And yeah, and so we can see that there's 2 more indices in the target than in the original that we didn't mention. And so hopefully we'll be able to realize, oh, that's right, this one has parentheses. So we can then just add the parentheses either here, or another place that we could add them if we wanted to fade them in separately would be just from nothing. Let's just fade in 12 and 15. And let's give that a look. Gorgeous. There you go. Oh, and again, I forgot to put the self.weight. Now, something that's maybe not so good about it is those, like if you really want to be a perfectionist, right? This tool allows you to be a perfectionist. I don't like how it starts to fade in before there's room for it. Like that too kind of moves through those parentheses. I'm not really a big fan of that. So no problem. Here's what I can do about it. I can just add a kwarg to say, wait a second before you come in here. Just wait 0.5 seconds. So unlike the other kwargs, which get passed straight to the corresponding animation, delay is a special one which causes it to wait a certain amount of time before it begins the animation that, is triggered by that entry. So now you can see it waits 0.5 seconds before they fade in, and I think that looks pretty nice. But maybe you don't like how long it takes to fade in now, so no problem. You can also just pass a runtime. It's got to be a string though. A runtime of, half a second. So now it'll be half a second runtime, and so now it'll look maybe a little more the way that you like. And they fade in faster now. Very nice. And then again, maybe you don't want the fade in, maybe you want a different introducer. You can just have it write those parentheses or any other introducer that suits your fancy. So I think it's pretty useful tool. Notice how I didn't have to tell all these other glyphs where to go. I didn't tell this plus where to go, this for where to go, anybody else. I didn't tell anybody else where to go, but they all know. They all just work out for themselves where they're supposed to go. And I think one of the coolest ones to think about or notice is the fraction bar. Notice how the fraction bar changes lengths accordingly, right? I didn't tell it to do that. It just knows that it has to go from the index it was already at to the index it was at now. And so it all works it out. So pretty useful tool. I use it a lot. And I hope it can be useful to you too. You can install it just with pip install mf tools. And you can check out the source code on GitHub. All right. Peace. By the way, I said earlier I was complaining how none of the native Manim transformations understand the algebra of the expressions that they're working with. Obviously, mine doesn't either, right? It just sees symbols and no algebra. It doesn't understand anything any more than Manim does. It's just a shorter syntax of telling it what to send where, but it can't tell a parentheses from a 4, from an x, from a pi, any more than the native Manim solutions can. What I was talking about is I'm also working on another package which is intelligent in that sense. It actually comprehends the algebraic structure of the LaTeX expressions that it is rendering. And through that intelligence, through that understanding, through that structure, it is able to automatically create the glyph maps for what to send where. It understands distribution all by itself. It understands, DeMoivre's theorem or anything all by itself, at least in theory. That's the idea. It is not done, but it is also on my GitHub if you want to check it out. I think it's pretty cool, but it is not done. It is not done. But that's another thing that I'm working on, and I'm really excited about it, and I'm really excited to show it to people when it is more finished. That's what I was talking about. Stay tuned for that. Oh, and I am going to be making a course about Manim. I'm going to be posting videos about how to use Manim for beginners to intermediates, and so subscribe if you want to see that. Okay,